Hi, Year 7. This is the second lesson on our topic of elements, atoms, and compounds. I am not going to give you the title for today's lesson because I'm sure you can work it out from the splash screen. First of all, we need to see how much we can remember from yesterday's lesson. Remember, we have to learn the names of some of the atoms in the first 16. So here are 8. Just quickly write 1, 2, 3, 4 in your books. Write down the names that match these symbols, and then write 5, 6, 7, 8, and write down the symbols that match these names. So pause the video and do that now. Okay, here are the answers. So you check your answers. Okay, so let's look at what we need to learn today about atoms. We need to know what an atom is, how big it is, and how to describe different types of atoms, and compare the properties of an atom and the properties of an element. And for those who want to do a bit extra, to learn the names of some of the parts of the atom. One of the things that has amazed me from history is that Democritus was a Greek philosopher, which is what they called scientists, 2,500 years ago, and he had a theory of matter. And this is what he said for his theory. All matter is made of atoms. Atoms are too small to be seen. Atoms cannot be further split into smaller portions. That is something for you to think about, whether he got that right or wrong, or almost right. He said the empty space between atoms, and atoms are different in size and different in weight. Well, these are the main things we need to learn about atoms. All matter in the universe is made up of atoms, not just on Earth, but the entire universe. An element is made up of billions of identical atoms. There are about 118 different atoms, and they make up 118 different elements. And just to give you an idea of the size, there are more atoms in one of these grains of sand than there are in all the grains of sand in the entire Earth. Atoms contain these 3 subatomic particles. So the atoms are made up of smaller particles. And here they are. They're called subatomic particles. Subatomic means smaller than an atom. So the 3 particles are protons, which have a plus sign. They have a positive electric charge. And neutrons, which are the red ones, which have no charge at all. And electrons, these blue ones with a minus sign, have a negative electric charge. All of these together, the neutrons and protons, make the nucleus. And then the electrons orbit round and round the nucleus in something called shells. The next question is, how big is an atom? And they're very small. And to give an idea of how small, 12 grams of carbon would be like a really small piece of coal. And this is how many atoms are there. So each one of these is 1,000. 1,000 is a million. That's a billion. That's a billion atoms, and a few more. So there are very many atoms in just a small gram of carbon. Have a look at this animation. It was taken with an electron microscope, which is the only microscope which can see or can show down to the size of an atom. It shows individual atoms in a piece of glass. And have a look at how they move and how they're arranged, because I also want to know what state of matter this is. So that's that one. Also, if you want to look at the internal parts of an atom, the subatomic particles, if you took the nucleus as the size of a pea and you put it on the center line of Wembley Stadium football ground, the electrons would be orbiting around more or less where the stands are. So the nucleus is very tiny compared with the size of an atom. And the atom is very tiny compared with anything that you can see. YouTube won't let me embed videos into a PowerPoint, so please go through the PowerPoint that's up in EduLink and look at these two videos, especially this one, because I think it's quite amazing. Scientists have been trying to cram more data into smaller spaces, more memory into smaller spaces, which is why your phones now have so much memory in them. And in doing that research, they found they were able to move individual atoms. So they had a bit of fun and they wanted to make a stop motion movie, which would be the world's smallest movie. So have a look at that. Click on the PowerPoint. The next thing to look at is how heavy atoms are. If you look at silicon, 1 cubic centimeter weighs 2.33 grams, and gold weighs 19.3 grams. So you can see gold is quite a lot heavier than silicon, and that's because each single gold atom is heavier than a single silicon atom. So the same number of gold atoms will be heavier than the same number of silicon atoms. And perhaps you can work out how much heavier gold is than silicon, and you use the data in this table to help you work that out. Here are three items made up of elements. This is made up of the element copper, the element carbon, and the element helium. The most important thing to remember is that copper, the element copper, is made up of only copper atoms. And the element of coal, which is carbon, is only made up of carbon atoms. And these party balloons, the contents are helium, and these are helium atoms. Just to reinforce that idea, these are elements of. I think about elements of carbon. It's carbon could be black, carbon can burn, and carbon at high enough temperatures can melt. Okay, like the clock did. But the atoms can't melt. Carbon atoms aren't black, and carbon atoms can't burn. I found it interesting to realize about gold medals when I researched this. The gold medals are made of silver, and that's the obvious reason is because look how much cheaper silver is than gold. Silver's $21 an ounce, and gold is $1,800 an ounce. So the way they make gold medals is they make them of silver, and they electroplate it with a really, really thin layer of 24 karat gold around the outside. And the bronze medals, there is no element of bronze, so it would be interesting for you to find out what bronze medals are actually made of. And remember, all this extra work that you might do, write it down neatly and send it to me. These are house point efforts. That's all there is to this lesson. The main thing though is to remember to do any worksheets, and there is a worksheet up on EduLink, and even though this video is quite short, the worksheet is quite substantial, so spend some time doing the worksheet carefully. And that ends the lesson for today.